Hey everyone, it's time for a new video, and this time we are focused on movement. So we're going to get this cube to move around the screen. Now I'm going to show you three methods that will work really well, and you can pick whichever one is best for your game. It really depends on what you want to do. So we'll start with, let's set up our scene, and we're going to put a plane under the cube. So let's just change our locations real quick. In fact, I'll just take the cube and move it up about half a unit, 0.5. And you'll notice right away, it's hard to tell what's what, so I'll put my red and blue materials on. Maybe I should make a new material because of that script that we made. I don't want to confuse anyone. I'll make a green one, color it green, and throw that onto the plane, so it'll be like grass. Okay, so we got a blue cube on some green grass. Now, what I want to do is I want to take that cube, and we're going to start coding a little bit to get it to move around. So I've created a script called movement, and what I want to do first is I want to translate the object. We're going to use the translate method. Translate is going to take the relative forward direction of the cube, and it'll use that to determine a motion. So let's start off by creating a public vector3 value, because a vector3 is used for position. So I'm going to call this my translate. Now I also want two more values, public float x float. As you guessed, this is going to determine the x translation value, and public float z float. Now, when you're creating a very large program, you might use private variables, but for learning purposes, public is a little bit more informative. It'll let you track values as you're working with this. So we don't need to put anything in start. Let's do everything here in update. The default value for each of these is 0. So 0, 0, and 3 zeros. What we want to do is in update, we're going to write the following. Xfloat equals input.getAxis, and then we're going to tell it horizontal. So that means if I press the left or right key, or the A or D key, then it's going to take a value. We're going to say zfloat equals input.getAxis, and this time, as you guessed, it's vertical. If I press the up or down key, or the W or S key, it's going to get a value. Now we want to say my translate equals new vector3 xfloat. So we have to determine all three values, the x, the y, and the z. For the y, we want it to be 0.5 f. Don't forget f because it is a decimal. And then we'll take our z float. And what this is going to do is every time I press left or right, it'll translate to the left or right based on the relative forward direction of the cube. If I press up or down, it'll translate up or down based on the relative forward direction of the cube. Sorry, z is not up or down, z is forward and backward. Y is up and down. That's why we didn't want to set a value for the y, otherwise our cube would move off of the plane. So let's save this, and we have to consider the following. We haven't done anything for our game object yet. So the next logical step would be to translate our game object. So we're going to say transform, because the position is part of the game object's transform. So when we put transform, by the way, it's actually going to refer to this game object's transform component. And the next thing we want to say is translate. And inside of transform translate, we want to put my translate, and then we'll see what happens. You'll notice when I hit play, let's select the cube so that we can see our script. We actually have to put the script on the cube. That would be a good thing to do. We've got this like massive flying going on. Our y value is changing tremendously. In our script, we set our y to 0.5. That was actually a mistake. Translate does not set the position. It actually sets the change in position. So for the y, we actually want that to be 0. So let's go back to our Unity program, and let's attach our script, because you have to do this outside of play mode for it to save. So it's the movement script. And then notice how all our values are 0. We'll hit play. Our value should still be 0. Nothing happens. Great. If I press the left key, my x value will go into the negatives, and we should see a translation. Ooh, that happened very fast. Notice how in the scene view, the cube is way off to the side. If I press right, it should come back on screen. If I just barely tap it so that there's almost no translation, cube can kind of move under control, but otherwise it's totally out of control. So what do we want to do? We want to edit something in our script. When you translate, you put in a vector 3 value. Vector 3's can be multiplied by other values. So I can multiply by 0.01f. That will make this 1/100th of the speed. Go back into Unity, hit play. With my new script, I should be able to control my cube a lot better. So there you have it. Cube's much, much better. But you can make this even better than that by changing this out. See, the problem with this is it depends on the person's computer. Update will call a different amount of frames for a faster computer compared to a slower computer. A faster computer will have more frames, a slower computer will have less frames. So you're not guaranteed that both computers experience the same thing. What you would rather do is compare it to the amount of time that passes in between each frame. Modify it by the amount of time that passes in between each frame. That's time.delta time. If you do this, then we're not just setting a value for this, we're actually making it whatever it was per second. So that if the magnitude of this vector was 1, then it would be 1 unit per second. So let's save that, and I'll kind of show you what I'm talking about. If I hit play and I start moving my cube, it'll take 1 full second for the cube to move from point A to point A plus 1 unit. So I'll hit play. It takes about 1 second for the value to change by 1. You'll notice if you check the position, so I'm going to hold left now, and it should go down. 2, 1, 0. So it takes about 1 second every time the position changes by 1 unit. Oh, also just to demonstrate, I haven't been doing any forward and backward, but you still have control of that with this script. So if I press down, it goes backward. If I press up, it goes forward. And this is all relative to the cube's forward position. I want to introduce a rotation of 45 degrees, not on the X, but let's go on the Y. Just to show you what happens if I press down with a rotated cube. Since I've rotated it to the right, and I press, the down key, it will go down relative to the forward direction of the cube, backwards. If I press the up key, it'll go forward relative to the forward direction of the cube. If I rotate it 90 degrees and then I press the up key, which would normally go forward, it should now go to the right. So that is transform translate. Let's do the second motion pattern. So this is translate. Second method of motion will be an actual position change. Position changes are slightly different because they don't involve the forward direction of the object. So what we want to do is, instead of translating our object right here, we want to say game object dot transform dot position. So we're going to actually set the position directly right here, equals game object dot transform dot position. So we're basically saying it's equal to itself plus our new translated value, my translate. Now you want to include this line over here, dot normalize, so that if you were to press up and right at the same time, you'd move just a 1 unit distance rather than, we could do the math here. I can go to paint. If you got a triangle, this will be to the right, this will be up, and when you add those two vectors, you get this, which if that's 1 and that's 1, that would be the square root of 2 in terms of length. So if you put dot normalize, then instead, then when you press both, it'll also be a unit length of 1. It would just be a shorter arrow. So it'll go in that direction. Okay, so let's go back to our script. Dot normalize does that. And we want to multiply by time delta time. So that way it's per second again. Hit save. And then we'll go into Unity. And the difference here is this time I will move, left using the left key. I'm going to rotate 45 degrees. Actually, I should do that in the Y. Got to be consistent. I'll press left again, and it still just goes left, even though I have now changed my direction. I can press right, it goes right. I can press down, it goes backwards. I can press up, it goes forwards. And you can verify that with the position values over here. So that's one advantage of using the position changes. However, if you want to use the forward direction, it might be better to translate. The third way you can do movement is if you take that cube and you go to add component, we can add a rigid body component, which is in physics, rigid body. The rigid body component will give it mass. It will give it gravity as well. So now this cube is sitting on top of the plane. Now, if you're going to use a rigid body component, make sure you don't have any lines of code that are setting the position. Otherwise, that's going to break it. So what we want to do is right over here, we have the same general setup, except this time we're going to go up at the top and let's create a new variable, public rigid body. We can call that RB. Now down here, what we want to do is referencing that rigid body. Actually, let's go to make a start function, void start. Doesn't matter, private, public, whatever. RB equals GameObject.getComponent, rigid body. Put the parentheses on the outside and then hit a semicolon. This will get the rigid body component from the game object the script is attached to. We can say RB dot add force and then my translate. Now this time, because we're adding a force, it's actually going to move the cube a little bit differently. Notice how I did not put the time delta time. Now let's see what happens. So I'm going to press right. It should start moving to the right. Take a look at the transform values. It's not going very far, very fast. In fact, it's hardly doing anything at all. So let's verify our script is working. We have the rigid body. We have the myTranslateX, but our cube's not moving. Forces won't directly move your object. They will accelerate your object. And when we have this thing called friction between the cube and the ground, friction will oppose motion, usually. So that means you need a certain amount of force to overcome that friction. Let's take this value and multiply it now by, let's say, 7. By multiplying it, I should now have enough force to move the cube. So I press and hold right, and my cube slowly is gaining some momentum. But again, there's still too much friction. Let's try 27, much higher value. Gotta be careful with this one, it might shoot off to the side. I'm not sure. Okay, so my cube starts rolling. Can you see that? I'm using the arrow keys left and right, and it's rolling, bouncing around. I can press down, bring it backward that way. Oh, check it out, it fell off the plane. When you put a rigid body, you are saying it has gravity. If I turn off gravity, however, this is how it would act. It kind of appears to be sliding. It's almost like friction doesn't play that same role anymore. Oh, I hit the edge of the plane, and now it's going to fly upward for probably forever. So that's motion with a rigid body. If you wanted to make this more smooth and still keep gravity, what you can do is you can go to create, make a physics material, call this frictionless. Oops, can't spell today. Go to the frictionless material, turn both frictions down to 0, and then make the friction combine minimum. And then drag this frictionless this frictionless physics material onto the plane. So now the plane has a frictionless physics material. And then make sure gravity is on, and we can test this. Since the plane is now frictionless, the cube will slide freely. It's not going to trip up on anything. And we've got a moving object. So those are the 3 methods. You can add a force, you can change a position, or you can translate.